So good morning, everyone. Let us continue with the operating system subject where we will see the scheduling algorithm in continuation. I will just quickly give you this explanation about non-preemptive SJF. The reason is yesterday few students also were confused with respect to non-preemptive SJF. I'll just quickly give you the idea how exactly your non-preemptive works, right? For example, if I have a process P1, P2, P3, and P4, I was having the arrival time, which was given over here. Burst time is 7, 4, 1, and 4. Now, whenever you are talking about non-preemptive shortest job first, non-preemptive indicates that whenever we talk about non-preemption, it means it is basically executes the process until and unless it completes its burst time. तब तक मेरा process processor से बाहर नहीं आता है जब तक मेरे process का burst time खत्म नहीं होता. That is called as non-preemption, right? So whenever in your exam question is asked based on non-preemptive, first of all, whoever process came first, arrival time was 0, so P1 will start its execution. Later on, you have a burst time 7. So if I start from 0, let us say it will end at 7. Normally, a Gantt chart is started from 0. So P1 will finish its own task. If you observe, now the time is 7. So by the time 7, process P2, process P3, process P4 have been already arrived, maybe at 2, maybe at 4, maybe at 5. So that means by the 7th time duration, all the other 3 processes have been arrived. So for this, now we have to decide which process we have to go for. We have to go for whether next process has P2, P3, or P4. The processor will observe the algorithm is shortest job. So the job which is shorter one is nothing but P3. So the next chance will be given by the dispatcher from ready to running queue is to P3. Since it is non-preemptive, so P3 will complete its execution. Its burst time is 1, so it will be given as 1, that is 8. After that, I have again P2 and P4 are remaining. Both are having the same time duration. So in this scenario, P2 will first get executed because it came first. So in case of, I'll just check the mic. Maybe the voice is a little low. I'll check the mic. Okay. Is the voice okay now, everyone? All right. So when you talk about P2 and P4, they both arrived at the same time. So the next chance will be given to the one who have arrived first. And that's why P2 will be given the chance as next. It is having a burst time as 4. 8 plus 4 is equal to 12. After that, P4 was remaining. P4 will have the next chance. It is having the 4 as basically the burst time. So 12 plus 4 will give me answer as 16. So this is called as a Gantt chart for non-preemptive SJF. Now, when you talk about waiting time in this scenario, the waiting time is basically the time which is for P1 when it got the control. Now, the arrival time for P1 was 0. It got the control at 0. So 0 minus 0, that is 0. 1 minute. The outside vehicle noise. Anyways. So when you talk about process P2, P2 have arrived at 8. P2 have got the control at 8. But P2 was having the arrival time as 2. So 8 minus 2 is basically 6. That's why the waiting time for P2 process is 6. If you observe P3 have got the control as 7. So 7 and its arrival time was 4. 7 minus 4 is equal to 3. That is nothing but the waiting time for my process P3. Similarly, P4 have got the control at 12. Its arrival time was 5. 12 minus 5 is equal to 7. This is how you can calculate a SJF non-preemptive process as well as you can calculate the waiting time for them. There was little mistake while explaining in the yesterday, but now I hope you have understood in a proper way. Everyone? Yes or no? Yes. So this is basically non-preemptive SJF, and we have already seen a preemptive SJF in the last class, which is also called as shortest remaining time first. In this case, जैसे ही जो process का arrival time आएगा, at that moment, previous process gets preempted. Preempted means from the running queue, it will go into the ready queue once more. That is called as preemption. When do we preempt the process? It is basically when the process may receive some IO request, when the process receives that other process have been arrived and I have to stop it, then I will go for from running to ready state one more time. So that is basically called as preemption. And when the next time the process is getting chance from ready to the running queue, that is the job done by the dispatcher. So dispatcher background में ये combination of algorithms use करता है to move your processes from your ready to running queue. That is basically called as shortest job first, preemption and non-preemption category. Next, we will see the priority scheduling. So in today's class, first we will observe the other algorithms of this, and then we will see the inter-process communication and deadlock. So a priority number is associated with each process. So let us understand this. P1 is basically having the burst time as 10. P2 is given 1. P3 is 2. P4 is 1. P5 is 5. In this scenario, the priority is given to each process. So how do we solve it? first priority is given to P2. So the lowest number indicates the first priority. अब P2 को priority है 1, तो पहले P2 execute होगा. Now P2 is having the burst time as 1. It will execute from, let us say, 0 to 1. Next, second priority is given to P5. So second P5 will get executed. What is its burst time? It is for 5 milliseconds. So from 1 to 6. The third priority is given as 10. So P1 will execute and 6 to 16. Next priority is given to P3, which is called as only 2 burst cycle. P3 is having 16 to 18. Next, P4 is having the last priority, but it requires only burst cycle 1, so 18 to 19. Now, if you observe and let me know, I'll just take this Gantt chart. I'll just take this Gantt chart and I will take, just a second, right. Now, if you observe and if I ask you, can you please tell me the waiting time for process P1 in this scenario was how much? 6. Waiting time for P2 was 0. Waiting time for P3 is 16. Waiting time for P4 is 18. Waiting time for P5 is, let us say, 1. Right? Now, also if you observe the process which is P4, assume, right? P4 ko burst time kitna hai? 1. Right? P4 requires burst time or the execution time is only 1. 1 burst cycle के लिए P4 को कितना milliseconds let us say wait करना पड़ा? 18 milliseconds, right? So in a case of priority scheduling, suppose now what happens? This process first, let us say पहला priority था P2 को, priority 1. P5 was given as priority 2. P1 was given priority 3. P3 was given priority as 4. P4 was given priority as 5. Now assume what has happened in between. In between, suppose P1, P2, P5, P1 got executed because of their priority. And in between, there is operating system gives me one more processor, one more, you can say, one more kind of this particular process. And assume I'm saying that is my process PA, which is having the priority, let us say again 3. Assume. Now what will happen in this case? Now my operating system will observe I have got a process who is having the priority 3. I have already waiting process who have priority 4. Obviously, as far as priority scheduling is concerned, तो पहले कौन सा process execute होना चाहिए? Obviously PA. Right. Suppose one more time process PB comes. Assume. And उसका priority भी अभी 2 है. Is it lesser than this priority? Yes. Again, PB will get executed. P3 and P4 has to wait for it. So what I want to conclude over here is, if the highest priority process comes before the lowest priority process, in that case, some of the processes may have to wait for a longer period of time and they may never get the chance also. This problem is called as starvation problem. This problem is called as starvation problem. Means my process P3 and P4 both are starving for the processor to get the control. Right? So let us understand what is starvation problem. So in case of starvation, low priority processes may never get executed. So a priority number which is associated with each process, in that case, we go for priority scheduling. Now, in case of priority scheduling, there can be a problem of starvation. अब अगर starvation का problem है, तो I need a solution for it. The solution is aging. What is aging? For example, suppose P2, P5, P1 have got executed. Now P3 is waiting for P3, which is having the priority as 4, and P4, which is having the priority as 5. They are waiting for me. Let us say my P3 process is waiting for from 10 minutes, right? Still, it have not got chance. Again, after 10 minutes, again my operating system will check. After 10 minutes, again my operating system will check, let us say, is the P3 process still waiting for me? Yes. So what your processor will do, or what your operating system will do, operating system will try to decrease its priority maybe by 1. Let us say, अब इसकी priority 3 कर देगा, अब इसकी priority 4 कर देगा. Again, maybe after 10 more minutes, OS will observe, oh, this process is still waiting. After some time slot, maybe its priority is getting decreased. Maybe it will decrease its priority. And after again 10 minutes, maybe it will see, oh, P3 and P4 yet not have got the chance. So again, it will decrease its priority. Again, it will decrease its priority, and so on and so forth. So अगर priority 1 पे आ गया, तो obviously वो process फिर execute हो सकता है. So this is a job which is done by OS automatically, and this is basically done so that the processes which were having the lowest priority, with the help of aging, solution to the starvation is aging, तो उनका priority कम होते जाएगा, and that process will not go in the starvation mode. That process will get the processor chance. Have you understood? So these type of questions are asked. In case of priority processing, the low priority processes may never get executed. That problem is called as starvation, and the starvation ka solution is aging. As the time progresses, it increases the priority of the process such that that process will get the chance for this. That is priority. Samajh mein aaya? Everyone, right? Next is round robin. What about the original priorities? That gets decreased, Rani. That gets decreased, and that job is done by your OS, managing of processes with certain time limit. That's why it is called as aging with some time slot, or maybe after some time slot, right? Next is round robin. In case of round robin, each process gets a small unit of CPU time. That is called as time quantum. For example, suppose I'm saying, let us take example. Which type of questions, Monali? I'm talking about these questions. कि priority scheduling में starvation क्या रहता है, priority scheduling में aging क्या रहता है. Based on the definition part, the question can be asked. Let us move ahead to the round robin. As the name says, round robin means every process will receive a chance for some processor to get some processor after some time period, line by line, maybe chance by chance. That is called as round robin. Now take an example. Process P1 requires total 53 burst time, 53 cycles लगता है. P2 requires 17 burst cycles. P3 requires, let us say, 68 burst cycles. P4 requires, let us say, 24 burst cycles. So in this case, I have given processes, I have given burst time. My operating system decides how much time will be given to each process for their execution. So maybe my operating system will find, okay, I will give 20 milliseconds to each process for its execution. Now, let me take the same diagram and I will explain over there. This I will save it first. Okay. Now, in case of round robin, we have decided the time slot or the time slice is given for everyone is 20 milliseconds. So it will check process P1 will arrive first. So process P1 will be given a chance for 20 milliseconds. So process P1 will get executed from 0 to 20. So can I say process P1 ka ab remaining time will be 30. Will it be 33? Because 20 have been executed, right? Next chance will be given to P2. अब P2 को मिलेगा 20 milliseconds, but P2 will say, I have only 17 burst cycles. So P2 will get executed from 20 plus 17 up to 37. Means can I say after this will become 0. Next, P3 will be given the chance. P3 will get the chance for 20 milliseconds, 37 to 57, right? So can I say this will become now 48 for me? Next, it will be given next to P4. P4 will get executed for 20 milliseconds, 57 to 77. So remaining time is still 4 burst cycles, right? So this is the first cycle that have been completed now. After that, again the chance will given to P1. P1 was 33. Again, P1 will get executed and 77 and 97. What will be the remaining time for P1 now? It will be 13. 33 minus 20 is 13, right? P2, does it require us to execute? No, it has been terminated. P3 will go 48, again minus 2, that is 28. This will become 28, right? And P4 needs only 177 to this, so this will become 0. Again, P1 will be getting the chance. P1 will execute for 13 seconds, 121 to 134, this will become 0. P2 is already completed. P3 needs 28, but the cycle is of 20 only. So P3, 134 to 154, remaining is 8. This have completed. Again, it will go into the round robin and it will check, okay, I have only P3. It will execute for 8 milliseconds and 0. This is called as round robin. Every algorithm will receive, or every process will receive a specific time quantum, and accordingly it will proceed. It always gives us a better average waiting time and a better response time. Here, the processors will never go into the starvation because each and every process will have the chance for its execution. Have you understood RR? That is round robin. Okay, let us go ahead to something called as multi-level queue scheduling algorithms. Yesterday, many students were asking me, if I'm saying I can execute only one process into my processor, then how it is possible that I can move or I can listen to the songs in the background and I can work on my application in the foreground? It is because when you talk about processor, the processor maintains multiple number of queues of processor. So what exactly queue is? Queue is basically maintained by the operating system based on the operations. मतलब प्रोसेसर के अंदर खुद से ही मल्टी लेवल क्यू स्केड्यूलिंग एल्गोरिथम है. There can be one queue may be given to the system processes. There can be another queue which can be basically having some interactive processes. There can be one queue which can perform batch processing. There can be one queue which is working on your foreground applications. There can be one queue, there can be you can say which can work on background processes. So a multi-level queue algorithms partitions the ready queue into separate queues, and the processes are permanently assigned to one queue. For example, if I say I am dividing my queue into two parts where I will have all the foreground processes and I have all the in background processes. So let us assume foreground may I'm working on, let us say, VS Code, and background may I am using some music application, right? So this is fixed, right? This is fixed means in case of multi-level queue, मैं background to foreground queue say, I'm sorry, I cannot move, or operating system cannot move this application to this queue and cannot move this application to this queue. This is fixed for the whole process cycle. That is called as multi-level queue scheduling algorithm. So the common division is made between the foreground and the background. But over here they do not move between the queues. एक बार उसको जो queue allocate हो गया वो उसी queue में work करता है. And because of that, we can have different multiple number of applications working simultaneously in your system. Foreground processes जिनको highest priority रहेगी वो foreground processes में हो सकते हैं, जिनको low priority रहेगी they can be in the background processes. So can you imagine how your processor is working in the backend, how powerful it is, right? So I hope you all have understood how you are basically getting two applications, one running in background, another running in foreground. Accordingly it will work. But there is another option for multi-level queue, which is called as multi-level feedback queue. For example, suppose I'm saying in my foreground, I have only one application, but in my background, I have multiple number of applications which I wish to execute. In this scenario, can I say foreground application or foreground queue is little empty, and background processes or background queue is having the heavier task to perform, or background processes is having more number of processes to execute? Yes. If this is the scenario, then operating system also does the management over here. What is that management? Few of the applications it will take from background to the foreground, so that the processing becomes faster. And when I switch some application from this queue to this queue, that means the operating system continuously analyze the behavior of this based on the feedback given by foreground queue. Some processes I may take in the background, I may take from the background to this foreground, and that is called as feedback queue scheduling algorithm. So it keeps analyzing the behavior of processes according to which it changes the priority. If the process uses too much CPU time, maybe it will be taking to the lowest priority. So sometimes अगर आप notepad या अगर आप command prompt open करोगे वो जल्दी से open होता है. VS Code थोड़ा ज़्यादा time लेता है. So it is because there are some applications which are heavy. So those applications takes time for their execution also. So it is based on the process to process which is getting executed. Maybe some priority based wise category कर सकता है. Maybe based on the execution steps. Maybe based on the time taken by the application. So that complete decision is taken by your operating system. Which algorithm I'm using, how many number of queues I have. So based on that, your multi-level feedback queue scheduling algorithm works. समझ में आया all the process scheduling criteria and process scheduling algorithms. So with this, we have seen what exactly process is. We have seen what is PCB. What do you mean by process state diagram? What do you mean by different types of algorithms which are called as algorithms of, you can say, scheduling, right? These algorithms are called as process scheduling algorithm or CPU scheduling algorithms. Also, we have seen different criteria of that. Any questions so far? If no, then we will proceed to something called as IPC. Okay, so next topic is called as IPC, which is called as inter-process communication. When we pass the information between processes, then that is called as inter-process communication. It is used to coordinate process activities. The processes within the system can be independent or cooperating. For example, let us assume I have a process P1. Let us assume I have a process P2. And let us say I have a process P3. So in my system, I'm working on 3 different processes. Now, the process P3 is saying, I do not want to share my data. I do not want to work with any process. I will work independently, right? So this process is different. This is saying I will work independently. So I will say the process P3 is called as independent process. What process P3 is called as? It is called as independent process. So there are certain processes which do not depend on any process for their execution. They work independently. That's the reason they are called as independent processes. Now, suppose I have two more processes, P1 and P2. And if I say the process P1 wish to share some data, maybe share some data, and with whom? Maybe with the process P2. That means I want these two processes to communicate with each other. And when two processes are communicating with each other, obviously there should be a cooperation between them. Otherwise, they will not be able to communicate. That is why they are called as cooperative or cooperating processes. So the processes which work independently, they do not want any interference or they do not wish to communicate with anyone, then those are called as independent processes. Cooperating processes means the processes which may wish to communicate with one another, maybe two processes, three processes. Now, when I say independent, तो obviously वो किसी के साथ communication नहीं करेगा. But when I say cooperating, those cooperating processes can communicate with each other with the help of a technique that is called as IPC. What is IPC? It is inter-process communication. So if some processes wish to communicate with each other, then they can go for something called as inter-process communication. So can I conclude in another way? Cooperating processes can only go for IPC. Independent processes cannot go for IPC. Have you understood what is IPC, everyone? Right. So let us read. So independent processes do not get affected by the execution of any other process. They do not share the data with any other processes. That's why they are called as independent processes. Cooperating processes get affected by the execution of other processes. The processes which shares the data among other, then those are called as cooperative processes. Why do we need cooperating processes? Because there may be something called as information sharing, maybe some speeder for speedy operation, maybe by achieving modularity, maybe for convenience and so on. So cooperating processes need IPC. IPC stands for inter-process communication. All right. Now, suppose I'm saying I want to go for IPC, right? Then the process P1 का obviously PCB अलग रहेगा, process P2 का obviously PCB अलग रहेगा, right? एक PCB से दूसरे PCB में मुझे entry नहीं मिलेगी due to the security reasons, right? So if I'm saying P1 wish to communicate with P2 or P2 wish to communicate with P2, P2 wish to communicate with P1, what is the solution for that? Answer is IPC. But how do we achieve IPC? It is having two categories. One is message passing, another is shared memory model. One is message passing, another is shared memory model. Now, when you talk about message passing, it is in the form of some messages which can be sent through the kernel. Can you observe? I have a process A and I have a process B. Process A wish to go for sending a message to process B, provided they both are cooperating processes. Process A will send a message to kernel, kernel will send a message to process B. This is how the communication will take place. This will not take place directly between process A and process B. Next, in the case of first scenario, the kernel is having a more operation to do. The job of the kernel will get increased. That's why the another model is shared memory model. So what exactly it is? If the process A and process B confirms that we want to communicate with each other, in that case, through some shared data or through some shared region. So kernel or your operating system gives us some kind of shared region for that. And when I say shared region, process A will write the data, process B will read the data from here. Process B will write the data, process A will read the data from here. This is called as shared memory model. Now, if process P1 and if process P2 both are cooperating और दोनों को shared memory region model use करना है, do you remember I have explained you the system called as SHM get? याद है क्या? तो shared memory get system call होता है when two processes wish to share the memory region. And why do they need that? That is present in the user space. Absolutely correct, Saurabh. But that will be available in the user space provided the system call, which system call gets called? SHM get system call hota hai. Okay, so communication takes place by means of exchange between cooperating processes using two primitives, that is send and receive. So this question can be asked in case of message passing, two cooperating processes communicate with each other by using which two primitives? Answer is send and receive. They are basically fixed primitives. Read write रहता है, send write रहता है, read and receive रहता है, whatever it is. But the correct answer is send and receive. These are the two primitives in case of message passing. The next category says shared memory. In case of shared memory model, a region of memory is shared by cooperating process is established by your operating system. The processes can exchange the information by reading and writing the data on the shared region. This is called as message passing and shared memory. In case of message passing, there are four things. One is a pipe, another is message queue, third is signal, and fourth is a socket. So, अगर मैं बोलती हूँ shared memory, तो सिर्फ shared memory region मिलता है and then they can perform the operation. But in case of message passing, it uses four primitives. One is called as pipe. For example, when I say I want to allow two processes to communicate in a unidirectional way, by using the pipe, one process can send a message to another process at a time. That means, suppose I am saying I wish to execute certain command. I will write a command through keyboard and my keyboard will execute that command or my system will execute that command. This is called as, कब मुझे खुद से मॉनिटर के थ्रू कभी मेरे पास कमांड आता है क्या? No. You can say this is called as one-way kind of communication. So when I have a unidirectional communication, in that case, they go for pipe. Now there are two types. One is unnamed, another is named pipe. When I say two related processes communicate with each other, that is called as unnamed pipe. And named means non-related processes can communicate with each other. Let us understand. Suppose I have one process and I have another process. Suppose process A, this is my process A, and suppose this is my process B. Suppose process A is executing one more process A, and process A is having one more child process B, and process PB is having one more child process, that is, just a second, yeah, this process is having a child process called as C. At this point, can I say A and B both are having the same parent called as PA? So I will say these are related processes. These are called as related processes. So the processes which have the same parent are called as related processes. But here B and C are not related processes because their parent is different. यहाँ तक समझ में आया? Everyone, have you understood what is related process and not related process? ठीक है. If I'm saying two related processes are communicating, अगर मुझे A और B को communicate करना है, then they can communicate. If they want to communicate through pipe, then that is called as unnamed pipe because they belong to, let us say, some same family, that is unnamed. But if B wants to communicate with C through the pipe, B can communicate with C in unidirectional way using pipe, but उस pipe के category को हम बोलेंगे named pipe. Have you understood what is named and unnamed? Everyone. So related processes means the processes which are having the same parent. जब not related processes रहते हैं, they can communicate with named pipe. These are some terminologies which are given, right? So pipe is one kind of message passing mechanism. Now second is message queue. The process is bidirectional communication. When the processes communicate with each other through send and receive or send, whatever it is. Maybe one process wish to send a message to another process, so that message will be having a destination address. Maybe the destination wants to send an acknowledgement, so that at that moment it can send an acknowledgement and it can give me the message. So this is called as message queue. If here the next two type of questions I would like to highlight over here is, in case of message passing mechanism, if two processes wish to work for IPC and if two processes want to work in a unidirectional way, which message passing mechanism they will go for? Answer is pipe. If two processes wish to communicate with each other, that too in bidirectional communication, in that case, that is called as message queue. Have you understood the difference between pipe and message queue? Everyone, right? Now, have you ever pressed Alt Control Delete on your system and फिर आपने end task किया है कभी, right? या फिर कभी कभी होता है कि आपका VS कोड या कोई एप्लीकेशन नहीं चालू होता है and वो आपको ऑप्शंस देता है, do you wish to close or you want the system to wait for it? Have you ever seen these types of scenarios? Right. नेक्स्ट, कभी कभी आपका मशीन बंद हो जाता है तो आप सीधा शटडाउन या रीस्टार्ट का बटन को 2 मिनट के लिए प्रेस करते हो और पूरा सिस्टम बंद कर देते हो एंड देन यू कैन परफॉर्म लेटर ऑन सम ऑपरेशंस, राइट? It means what? You are giving some direct signals to your operating system. Maybe when you talk about control alt delete and if you press end task, तो internally वो कौन से system को call करता है? It is basically sig kill. So there are sig terminate, sig kill, sig stop, sig continue. So ये सब क्या है? ये signals है. So if two processes communicate with each other by means of some signals, then that is called as signal. Right? So signals are having some predefined meaning. Signals, even though यहाँ पे भी unidirectional communication हो सकता है, but signals have predefined. For example, आप end task करते हो, तो आप पूरे process को kill कर देते हो या terminate कर देते हो. तो internally operating system क्या करता है? उस particular process के through sig terminate नाम का signal को call करता है. Have you understood? So they have some predefined meanings, and that is called as signal. And when you wish to communicate over the network, obviously you need an IP address, you need a port number, and for that type of communication can be done with the help of socket. So socket is basically an endpoint for communication. You need an IP address, you need a port number for being into the network. I hope you remember the concept of IP addressing in DCN. Right? So this is basically message passing mechanism done with respect to IPC. Have you understood, everyone? So IPC takes two categories, message passing and shared memory, right? Now, let us say, now we will go ahead to the next concept, which is called as process synchronization, right? Now, what is process synchronization? What is critical section? And we will see these two with one simple example. Now, let us say I'm saying I want to perform some bank transaction. Okay, and let us assume I am executing process P1, correct? And initially, I'm just saying view balance. This is my process P1 who is performing the task. Process P1 is basically next operation. It is saying deposit maybe 5,000. And deposit के लिए मैंने कुछ lines of code लिखा है, right? This is my program which is just performing the operation of deposit. Let us say यहाँ पे ये मेरा function हो गया, deposit नाम का function. After that, I'm saying commit. Commit means done. I'm done with the process. Maybe I'm writing done. And later on, if I say I just wish to view a balance one more time. Assume these are the steps which my process P1 wish to execute. Now, there is one more process, which is P2. P2 is also saying view balance. That's fine. P2 is working on withdraw application, where I have written few lines of code for withdraw to, and I'm saying done, and then maybe I'll say view balance. Now, if I say I am working on one specific balance keyword, right? So this is basically assume a balance variable. So assume process P1 and process P2 both are working simultaneously. I'll say process P1 and process P2 both are working simultaneously. Means what? Process P1 is also want to work on this balance. Process P2 also want to work onto the same variable of balance. So if I say both the processes P1 and P2 both will work at the same time, will it give me inconsistency in my data? Everyone, if both the processes are working on some shared data, in that case, if I say दोनों भी साथ में काम कर रहे हैं, then there may be a problem of data inconsistency. ऐसा हो सकता है? True. To avoid this data inconsistency problem, the processes must be synchronized. The processes must be synchronized. And that concept is called as process synchronization. Right? So when I say two processes are executing simultaneously, those processes are called as concurrent processes, or simultaneously they are getting executed. Now, concurrent access to the shared data may result in data inconsistency. So maintaining the data consistency requires a mechanism to ensure orderly execution of cooperating processes. Can I also conclude P1 and P2 cooperating है, इसलिए तो वो shared data पे काम कर रहे हैं? Are you understanding the scenario? Yes. Next. Now, the situation where several processes access and manipulate shared data concurrently the final value of shared data depends upon which process finishes last. This condition is called as race condition. Assume my process P1 is saying I wish to deposit 5,000. So process P1 will make it as 5,000. Next, suppose I'm saying now my chance is given to P1, right? I will need this same diagram one more time. I'll just first copy this instead of drawing it again. Just copy this. Okay. Assume I'm saying I am following round robin technique. I'm giving 5 milliseconds to each process. Suppose process P1 have executed its first task, it have viewed the balance and assume the initial balance was 1,000. Assume, right? That was my initial balance. Please observe very carefully. Initial balance was 1,000. Now, when the next time control is given for the next 5 milliseconds to the process P2 because we are using round robin. तो अब जब P2 को व्यू बैलेंस आएगा तो ऑब्वियसली P2 को भी 1000 ही दिखेगा. True. Up to this point, it is okay. But now, when for the next 5 milliseconds, when the process will say, I want to deposit 5,000. So can I say, अब मेरा balance 1000 में से 5,000 हो जाएगा? True. Again, it will say, I am done. Means now the updated value of balance is 5,000. Up to which point? Up to this point. Do you all agree, everyone? Right. Now, as I'm using a round robin fashion, now the control will be given for next 5 milliseconds to whom? Obviously to process P2. Now process P2 is saying, I wish to withdraw 2,000 rupees. Right? So if it is saying I wish to withdraw 2,000, that means balance में से 5,000 cut हो जाएगा and यहाँ पे 3,000 आएगा. Right? And now this will say I am done. Right? So last updated value is 3,000. Correct? Up when the process P1 will receive the next chance of a 5 millisecond, process P1 is saying I am getting view balance as 3,000. Means what? According to the process P1, I should get in my output as 5,000. As 5,000, as far as this is a separate program, this is a separate program, right? But what I'm getting, I am getting the wrong result because I have it have been updated by the process P2, which my process P1 is unaware about. Have you understood the scenario, everyone? Now, process P1 is saying, please add 1,000 more. So, अब इसी 5 millisecond में 4,000 balance हो जाएगा 4,000. When the next 5 milliseconds will be given to the process P2, अब in this scenario, it should have got 3,000, but उसको answer क्या मिलेगा? 4,000. Means, can I say here also, as far as my P2 process is concerned, the expectation was 3,000, but I have got it as 4,000. This category is called as race condition. So when multiple number of processes are trying to fetch the data from the shared memory slot, in that case, there might be the scenario we may receive some inconsistent data or we may think that I'm getting a wrong data into this, right? That's the reason we say we need something called as process synchronization. I try to explain you the meaning of data inconsistency and share race condition. When several processes access and manipulate the shared data, the final value of shared data depends upon which process have finished last. अगर P1 ने last perform किया तो वो updated value आई, P2 ने last perform किया तो वो updated value आई. This problem is called as race condition and this also leads to data inconsistency. Have you understood up to this point, everyone? So to avoid this scenario, we have a solution for that is maintaining a critical section. For example, suppose, can I say at this point, ये मेरा सबसे important section है, इसको मैं बोलूंगी critical section. इसको मैं क्या बोलूंगी? Critical section. Similarly, in this scenario, I will say ये मेरा सबसे important selection है जहां पे I am making modification into the shared data. This section is called as critical section. And I'll say In this scenario, when we will perform this operation, this is called as entry point for the critical section. This is for exit point for the critical section. This is the entry point for the critical section, and when this is called as exit of critical section. So the section in which, I'll just remove this for time being. So the section in which we try to access the shared data, that section is called as critical section, in which we can perform different operations only once. मतलब जब मैं डिपॉजिट ऑपरेशन परफॉर्म कर रही हूं, बैलेंस नाम का वेरिएबल सिर्फ लॉक हो जाएगा. Other processes will never be able to work on that balance until and unless मेरा P1 process have finished its task. Even though it is a round robin, even though it is any kind of algorithm, but if one process is in the critical section and if that process is trying to access some shared data, that shared data will be dedicatedly given to only that process until and unless that process have finished its job. So the section in which process P1 is executing operations on balance, that section is called as critical section. समझ में आया? So what is critical section problem? It is basically if one process is entering into the critical section till the time no other process will be able to have the accessibility onto the shared data, that is called as critical section problem or critical region problem. So the problem is to ensure only one process at a time is allowed to it. तो जब मेरा प्रोसेस क्रिटिकल सेक्शन में जाता है तो वो रिसोर्स लॉक हो जाएगा. योर कंपाइलर, योर ऑपरेटिंग सिस्टम विल नॉट गिव दैट शेयर्ड रिसोर्स टू एनी अदर प्रोसेस फॉर देयर एग्जीक्यूशन. दैट प्रॉब्लम इज कॉल्ड एज क्रिटिकल सेक्शन प्रॉब्लम. I hope with this diagram you have understood the meaning of process, the need behind process synchronization. What do you mean by race condition? What do you mean by data inconsistency? And what is CSP, that is critical section problem? समझ में आया सबको? Everyone. Good. So these types of technical conceptual questions are asked in your exams based on your topic. Race condition means हार्दिक, अगर मैं इसको क्रिटिकल सेक्शन में नहीं रखती थी, P1 भी बोलेगा मुझे बैलेंस चाहिए, P2 भी बोलेगा मुझे भी बैलेंस पे प्रोसेस करना है. So they are just starving for that shared resource to get control as soon as possible. That is called as race condition. Okay. All right. Any questions so far? Did you all get up to this point? Are you guys awake? All right. Starvation means waiting for this process to get the control. It's like starving for something, waiting for something to get the control. All right. If you all have understood race condition, Rishi, you can say, for example, kind of P1 भी बोल रहा है कि I need balance as a shared resource. P2 भी बोलता है I need a shared resource. So what is that condition? When several processes wish to access and manipulate shared data concurrently. Okay. Have you understood? So it's like this concept is called as you can say race condition. To avoid a data consistency, we need to be synchronized process. Synchronized process होने के बाद भी हमारे पास race condition का problem होता है because multiple processes can get the or wish to access the resource and manipulate the data. To avoid a race condition, हम उसको critical section में डाल देते हैं. Critical section में गया मतलब वो process, वो shared data जो है, maybe in our case it was balanced, maybe any resource can be there. That data is locked. And for that, actually, your operating system maintains something called as semaphore as one variable. So, अगर मेरा process critical section में जाता है, तो मेरा compiler semaphore को let us say 1 कर दिया. 1 किया मतलब अब मेरा जो भी critical section में process गया, उस particular resource की value 1 किया, means maybe it is locked. And later on, once its task is done, this value gets changed, means it is unlocking. इसलिए जब आप किसी भी फॉर एग्जांपल व्हेन यू ट्राई टू परफॉर्म एनी विथड्रॉ ऑपरेशन, व्हेन यू ट्राई टू परफॉर्म डिपॉजिट, तो आप दोनों ऑपरेशन एक साथ नहीं परफॉर्म कर सकते हो. ऐसे होता है क्या एग्जैक्टली सेम टाइम लिमिट पे या सेम टाइम ड्यूरेशन पे मैं विथड्रॉ एंड डिपॉजिट दोनों एक साथ कर सकती हूँ? ऑब्वियसली नो. एंड दैट इज बिकॉज I'm saying there are two processes. Processes are synchronized, but they can perform simultaneously. Once the balance will be getting, that means it will be locked by your compiler. Okay, locked by your OS. ठीक. Next is the next concept is called as deadlock. Now, when I say deadlock, in this case, let me explain one scenario. Suppose normally when in case of operating system, when you draw a circle, it represents a process. Maybe I'll say this is my process P1 and maybe I'm saying process P2. Let us assume P1 is using some resource R1 and that resource is, let us say, I'm saying that resource R1, which is printer. And P2 is using one more resource, which is basically, let's say I have resource R2 and P2 is using scanner. So if I try to draw a diagram, so it means P1 is requesting for printer, assume, and scanner is allocated to P1. P2 is requesting for scanner and P2 is using the printer. So I'll write it. P1, I'll say P1 is giving request for printer, which is being used by P2, and P2 is requesting for scanner, which is being used by P1. But the condition over here is P1 is saying, I will not release the resource until and unless I will get the scanner, or sorry, I will get the printer. Process P2 is saying, I will not release this printer until and unless I will receive the scanner. Are you understanding the scenario? एक प्रोसेस P1 बोलता है जब तक मुझे प्रिंटर नहीं मिलेगा तब तक मैं स्कैनर को रिलीज नहीं कर सकता. And P2 is saying, I will not release this printer until and unless I will get a scanner. So can I say, is it possible in this scenario? I do not have any other printer. I do not have any scanner. Rather, I do not have any additional resource so that they can get satisfied with it. So that means this is like, can I say P1 is waiting for P2 to release the resource? And P2 is also waiting for P1 to release the resource, right? P1 and P2 both are waiting in circular way, right? P1 says, I will not preempt. P1 says it will not preempt the resource. I hope you remember the meaning of preempt. Preemption means usko maine preemption and non-preemption हमने algorithms में देखा. Preempt means I will not give my control of that particular resource to some other access kind of thing. Yes, true, Monali. And P2 also says it will not preempt the resource, right? Also, P1 and P2 does not have any understanding between them. Okay, I will wait. You can go ahead with this. They do not have any understanding, right? So these can be the 4 possible scenarios in this. So the first point which I'm saying, P1 is waiting for P2, P2 is waiting for P1. This condition is called as hold and wait. P1 is holding scanner, waiting for printer. P2 is holding printer, waiting for scanner, and so on. Next, this condition is called as circular wait. They are waiting for each other in a circular motion, that is circular wait. And they are not even preempting the resource and vice versa. Absolutely correct. They are not giving me the resource, that is, they are non-preemptive, right? Also, finally, they are not having any understanding. I will wait for some time and give you the resource. That is called as mutual exclusion. These all are, I'll just change the color. So this is mutual exclusion. Now, if in the system, if 2 processes are communicating with each other, and if 2 processes are working on the resources, and if the 4 conditions, that is hold and wait, circular wait, non-preemptive, mutual exclusion, अगर चारों condition मेरे पास आ जाती है, then that leads to deadlock. That leads to deadlock. So what is deadlock? A deadlock is a situation when the processes are using the resources, but they have reached at the level where they have all the 4 conditions: hold and wait, circular wait, non-preemptive, and mutual exclusion. If all these 4 situations occurs while sharing of resources in case of processes, then that situation is called as deadlock situation. समझ में आया? Everyone, what is deadlock? So let us read it. Deadlock is a situation where set of processes are blocked because each process is holding a resource and waiting for other to do some process. A processes are in the deadlock when every process in the set is waiting for the resource that can be released by the another process in the set. For example, over here, P1 is waiting for this, assigned to this. P2 is waiting for this, assigned to this. Here also, R1 is given to P1, R1 is given to P1, P1 requesting for R2, R2 is given to P2, P2 is given, and so on. This is the state which is called as deadlock state. What are the necessary conditions for deadlock? Deadlock कब occur होता है? That means when you have a mutual exclusion, when you have hold and wait, when you have no preemption, and when you have circular wait. So if all the four conditions are available in your system based while sharing the resources, in that case, a deadlock situation occurs, right? The methods for handling the deadlock means अब अगर deadlock आ गया तो हम उसको handle कैसे करेंगे? One is a deadlock prevention, another is deadlock detection and avoidance, and can be a deadlock recovery. First, deadlock prevention. Prevention means अगर इसमें से एक भी condition unsatisfied हुआ, for example, P2 is understanding and P2 is saying, okay, I will release the resource. अगर P2 ने resource को release कर दिया, तो can I allocate this resource to P1 and later on this R1 can be given to P2. Means if one of the condition from these deadlock is basically tried to prevent it, then I can prevent the deadlock. So discarding any one of the condition out of 4 basically helps me to prevent from the deadlock. Next is deadlock detection and avoidance. It means that हम ऐसा algorithms भी implement कर सकते हैं जिससे I can avoid the deadlock and I can detect the deadlock. For example, suppose I'm saying I have a process P1, I have a process P2, I have resource R1, I have resource R2, maybe I will keep one resource in spare R3. जब process P1 is using R1, process P2 is using R2, process P1 is requesting for R3 or R2 and process P2 is requesting for R1. In this scenario, suppose R3 is also one printer, R1 is also one printer. Instead of that, I will give R3 and I can keep R1 for it. So it is basically या तो मैं कुछ spare resources रख सकती हूँ या फिर मैं proper graph बना सकती हूँ. That algorithm is called as resource allocation graph algorithm. Another algorithm is Banker's algorithm. So when you talk about which are the type of deadlock detection algorithm, one is RAG, resource allocation graph, and second is Banker's algorithm. So what actually they do before allocating a resource, जब printer अगर मुझे let us say P1 has demanded printer, P2 have demanded printer, right? In that case, maybe operating system will check, can I allocate process P1 को printer? If yes, then only it will allocate. Otherwise, it will say printer is busy. So उसे deadlock situation नहीं होगा. So deadlock can be detected or it can be avoided using the algorithms, and those names you must remember. These types of questions are asked as basically these algorithms are called as resource allocation graph or Banker's algorithm. Okay. Yes, there may be possibility, Pawan, in real life systems also. कभी-कभी आपका system hang हो जाता है, आपको कोई भी reply नहीं होता है, ना ही आपका machine चालू होता है, कुछ भी नहीं. That is nothing but one kind of deadlock situation. It's not always with the help of your processes and resources. But the thing is, normally in case of operating system, when you talk about deadlock situation, that occurs between the processes and the resources. Yes, only theory questions. All right. So when you talk about deadlock recovery, suppose अब deadlock आ भी गया. In that case, I have to either terminate the process or I have to go for resource preemption. What is resource preemption or what is process termination? It is basically, suppose system में आपका कोई when you click, let us say Control Alt Delete, and then you end the task, it means you are terminating that process. But have you ever observed कि आपको end task में भी बहुत सारे options दिखते हैं, whether you want to end Chrome, whether you want to end Word document, whether you want to end this document, whether you want to end disk processing, whether you want to end copy, तो आपको list of tasks दिखते हैं. अब वो उसमें से आप एक या दो task खत्म करते हो? Yes or no? So the process which you click for ending the task is the victim process. Understood? So the process which you selected and you terminated to recover from that deadlock, that process is called as victim process. समझ में आया what is victim process? Okay. And when I say resource preemption, it means my operating system will say, okay, you are not ready to release the resource. I will release the resource from my side. I will snatch the resource from my side from that process. At that moment, that is called as resource preemption. The control of resources taken away forcefully from the process to recover from the deadlock. So snatching one of the resource from the owner of the resource is called as resource preemption. It is because in this scenario, अब problem क्या आता है कि कौन से process का resource मुझे snatch करना है. In that case, we can say that a resource preemption will be done for the process who have completed lesser task. Again, operating system will do intelligence over here and it will check कि जिस process ने काम कम किया है उसी से ही process का resource ले लो and उसको बोलने का बाद में करो. So that is called as recovery from the deadlock. Shreya, resource allocation graph is one kind of algorithm. Normally, in your system, there are many resources. You can say your disk is also one resource, printer is also one resource, scanner is also one resource, your RAM is also one resource, your hard disk is also one resource. So in your system, there are different number of resources which can be used by different processes. So whether that resource can be allocated or not allocated, that can be done by the algorithm called as resource allocation graph. Okay, so which can avoid your detection and avoidance. So these are the basics of, you can say, process in which they are requesting for the resource and methods for handling the deadlock. समझ में आया everyone? So we have seen what are the process, what is PCB, PCB के criterias, memory structure, process and program का कैसे रहता है. Then we have seen process scheduling criterias, we have seen inter-process communication, and then we have seen something called as deadlock, right? Moving ahead to the next topic, which is called as memory management. So as far as process, as far as program was concerned, we have seen all the basics, all the concepts with respect to operating system. Now we will see memory management. It is a task which is carried by your operating system to accommodate multiple processes into the main memory. The reason is, आपका hard disk 500 GB का है, आपका RAM 4 GB का है. When you are executing multiple processes, any process which is not in the main memory means I cannot execute. I have to bring that process into the main memory for their execution. अब मेन मेमोरी में से मुझे कौन सा लोकेशन पे which process I have to load, which process I have to bring out from the main memory. Every task is done by your operating system, and that complete system is called as memory management. How effectively I can use my main memory in such a way that multiple processes can be accommodated into the main memory, as well as I can use that main memory very effectively. So for that, memory management is required. For example, the major role of memory management is called as swapping. Let us say this is my secondary memory, right? In my secondary memory, I have created processes P1, P2, P3, P4, up to Pn. Suppose in my main memory, process P1, process P2 are available. And suppose process P1 have requested for some print or some IO request. So process P1 goes out for IO wait. It is swapped out. Again, my main memory is free. So next process P3, as far as CPU scheduling criteria is concerned, जो भी मेरा operating system algorithm use करेगा, next process P3 को dispatcher लेके आएगा ready से आपके running queue में. Again, process P3 is saying I'm done with the task, I will swap out. Again, P1 will be taken in for swapping in. Swapping is a mechanism in which process can be swapped out from the main memory temporarily, and it is brought out from the main memory and back to the storage. If the system swap backs the process from the secondary storage to the main memory, that is called as swap in. So swapping out and swapping in can be done by your operating system such that when we execute multiple and big processes in parallel, we need swapping. पूरा का पूरा 500 GB का हार्ड डिस्क में मेरे मेन मेमोरी में नहीं ला सकती, या मैं उतने नंबर ऑफ एप्लीकेशंस एक साथ एग्जीक्यूट करके मेन मेमोरी में भी उतना ही आएगा जितना मेरे मेन मेमोरी का कैपेसिटी रहेगा. सो ऑब्वियसली अगर कैपेसिटी नहीं है, द प्रोसेस व्हिच इज करंटली गेटिंग एग्जीक्यूटेड विल बी ब्रॉट इनटू द मेन मेमोरी, रेस्ट विल बी केप्ट इनटू द सेकेंडरी मेमोरी. हैव यू अंडरस्टूड द मीनिंग ऑफ व्हाट इज स्वैपिंग, एवरीवन? ऑल राइट. नाउ there are two major types of partitions in your system. One is fixed partition, another is variable partition. So when I say memory, in my main memory, there is one part which is OS, obviously that is available. If I say in case of fixed partition, then suppose I have a memory, and inside this memory, I'll say I will have three parts. The first part, maybe the second part, the moderate one, and the larger one. So I will say this is a small block of memory, which I will be using for my storage purpose. And maybe I will have to, this basically is a medium one. And whenever I'm saying this is the largest block which is available for my memory. This is like kind of, you have done, let us say, hard disk partitions, right? तो जब आपने पार्टीशन किया तो आपके ऊपर है कि आप 100 GB का करो, 500 GB का है तो you can make 5 different partitions, 100, 100, 100, 100, or you can say 250, 250, or maybe you want to go for 200, 200, 100. This can be done only once for your hard disk. Do you all agree? That is called as fixed partition. But at this stage, I cannot even decide कि मेरा smaller block जो है वो कितने bytes का होना चाहिए या कितने GB का होना चाहिए. I can also cannot take a decision at the later stage कि medium का मैं कितना block size रखूं. I also cannot take a decision कि what will be the largest block size. But if I say I am working on fixed partition In that case, the processes are classified on the entry to the system according to their memory requirements. Now, suppose I'm saying, I will say in my range of the small block is from 1 KB to 10 KB. That's it. Maybe मीडियम साइज का जो ब्लॉक है मेमोरी का जिसमें आई कैन कीप फ्रॉम 10 KB to 100 KB एंड 100 KB से जितने भी बड़े प्रोग्राम्स है मुझे लार्ज ब्लॉक में ही आने चाहिए. So if I say I wish to execute process P1 and process P1 requires only 2 KB. Similarly, if I say I wish to execute process P2, this process P2 requires, let us say, 15 KB. In this case, operating system again takes a decision. P1 requires only 2 KB. Let me add P1 at this location in the smaller block. यहाँ पे वो queue maintain करता है. P2 requires 15 KB. That means I have to take it into this medium block for its execution. So based on the requirement or memory requirement of the processes, the blocks are moved into either the small or medium or the large block. The number of fixed partition gives the degree of multi-programming. मतलब multiple programming करने के लिए we need a number of partitions and accordingly we can go ahead. Since each queue has its own memory region, it is no competition between the queues. मतलब अगर मेरे पास 10 processes भी आते हैं जिनका range 1 KB to 10 KB है तो सारे small queue में ही wait करेंगे. If I have processes for medium queue, everyone will wait into this queue. If I have processes for large, they will wait in the queue. There will be no intermediate competition between them. One by one, memory will be allocated to them and they will get executed. This is called as fixed partition. But the problem with fixed partition is how to determine number of partitions and how to determine the size of each partition. That is called as fixed partition. So in case of fixed partition, once the size is fixed, we will say that हमेशा processes जो इस small block में आ सकते हैं, they will go into that queue. Next is variable partition. For example, if one of them is full, obviously Arpit, it means memory is full for the small region. Other processes have to wait. Okay, Arpit? All right. In case of variable partition, here the whole memory is free and it is considered as one large block. When the new process arrives, the OS searches for the block of memory large enough for that process. For example, let me take this diagram. Let us say, I'll take this. In case of variable partitioning, the operating system maintains this scenario. Let us observe. It maintains a pair of base and limit registers which defines the logical address. Suppose process P1 have arrived. Okay. Now, if the process P1 have arrived, P1 will receive the data maybe over here. Next, process P2 have arrived. Process P2, assume it will get the memory location over here. So every time my operating system has to understand कि process P2 का size क्या है. The reason is, if I'm saying the first base address for the process P2, I have given as 300040 and process P2 is ending at, let us say, 420940. Means I am concluding that process P2 requires only from this location to this location. इतना ही memory मेरे process को चाहिए. So the operating system maintains the base register as a starting register into its one register, which is called as base address. So what is that base? Base is nothing but the starting register, starting address. And your operating system has to maintain its size also because it is variable partitioning. That means whatever number of size it requires, difference between this and this is this one. This is called as limit register. It maintains the size of that process. समझ में आया? So in case of variable partitioning, the operating system has to Operating system has to maintain the base and the limit register. The reason is base से उसको पता चलेगा कि process is starting at this location. Limit से उसको पता चलेगा this is the size of that, and that is called as variable partitioning. Have you understood the two categories of partitioning? First is fixed partitioning and second is variable partitioning. Fixed में जितने भी processes रहेंगे small वाले small block में ही जाएंगे, medium size के रहेंगे वो उसी में वहां पे जाएंगे, large वाले large में जाएंगे. There will be a queue maintained. But in case of variable partitioning, the whole memory is free, considered as one large block. That is called as variable partitioning. Have you understood, everyone? Now, when I talk about block is to be given, then that is called as allocation. For example, let me cover, if I say I have one large memory block, right? This memory block is having different number of blocks with different sizes and so on. Now the question is, if any process comes, suppose process P1 comes. Now this process, and assume I have all the free blocks available for me. मेरा पूरा memory free है उसको load करने के लिए. Now the question is, P1 process, whether to be stored over here, whether to be stored over here, whether to be stored over here, whether here or whether here, right? Suppose existing memory location है this one, out of which this block is basically used by someone. Assume this block is also used by someone, and I have only this free block, this free block, this free block, and this free block. So the one which is in this color is basically the available blocks for me. Assume these are the available blocks, right? And the blue ones, which are maybe used by others. Maybe some processes are already available in that memory block. Now, if process P1 comes, the question is, if process P1 is coming to me for the loading into the main memory, the thing is, should I load this process P1 in which block? For that, I have something called as allocation techniques. Process allocation techniques means where should I load this process P1? And for that, I have 3 allocation techniques. The first is first fit. The second is best fit. And the third is worst fit. Have you understood the need of allocation techniques? Got it? So the first fit indicates, let us observe how. हम लोग ये definition बाद में देखते हैं. Assume this is my original OS memory. P1 available है, यहाँ पे मेरे पास free है. P2 is 20 KB, 16 KB is free. P3 is available, which is getting executed, and this block is free. Suppose this is my initial memory mapping. Means currently my scenario of main memory is like this. So P4 आया 3 KB का. What does the first fit algorithm will do? First fit algorithm will first observe which is the first free block available to me. Can you please tell me which is the first free block? जिसका size कितना है? 10 KB. Can you see this? Obviously yes. So what does it will do? The first fit will observe what is the need of P4, 3 KB. Which is the first free block? 10 KB. Load it over here. Observe this. This will be loaded over here. Remaining will be 7 KB. समझ में आया first fit क्या है? So first fit algorithm selects the first free block which can accommodate your process based on the size. That is called as first fit. Next, this is first fit. Again P5 comes. No, जो not like priority. जो पहला first block free मिलेगा and जिसमें मैं accommodate कर सकती हूँ. Let us consider P5 of 15 KB. अब पहला block कौन सा है? 7 KB. Can I accommodate P5 over here? No. So can I accommodate P5 over here? Yes. So 16 KB में के यहाँ पे P5 upload किया and then 1 KB is free. This is first fit. Whichever is the first free block available for loading the block, that is first fit. Have you understood? So now read it. It allocates the first free block that is large enough for the new process. And this is the fastest algorithm. वो starting से search करेगा, जो first block है, size compare करेगा, load करेगा. That is first fit. Let us see the best fit now. We will read this later. Assume this is my initial memory mapping. 10, 16 and 4 all are available for me. P4 process आया. P1, P2, P3 already are there. P4 is of 3 KB. It will compare who is the best suitable block for me to load P4. Can you please just give me a guess? Obviously, this one, P3 के बाद वाला block, right? So P4 will be loaded over here into 3 KB area. 1 KB will be free. So this is called as best fit. Suppose P5 आया. P5 के लिए best block कौन सा है? यही block है. So it is best fit mate will get uploaded. 1 KB will be free. So what does the best fit do? Let's read the theory. It allocates the smallest block among those that are large enough for the new process. In this method, OS has to search the entire list, right? पूरे memory में कौन से blocks available है, कितने size के available है, and process का size, ये सब compare करके accordingly it will load the basically process into it. Now can I say अगर मैंने यहाँ पे P3 load किया, सिर्फ smallest 1 KB का block ही empty रह रहा है. Can I say like this? Everyone, if I'm loading 15 KB, a smallest block is still empty into this. So I can say In case of best fit, it produces the smallest leftover block. It produces smallest leftover block. Okay, let us consider worst fit now. What is worst fit? It allocates largest block among those that are large enough for the new processes. Consider the same scenario. This is my original mapping. Process P4 of 3 KB comes. अब सबसे बड़ा ब्लॉक कौन सा है? 16 KB का है. वर्स्ट फिट क्या करेगा? उधर ही वो लोड कर देगा 3 KB को. Remaining will be 13 KB. So can I say P4 of 3 KB will be loaded here by the worst fit. अब P5 का 15K का मैं लोड कर सकती हूँ क्या? Obviously no, I cannot because I do not have large enough block to load that process. तो मतलब P5 को फिर से वेट करना पड़ेगा. So that is what in this case a worst fit basically searches for the entire list and it produced largest overblock. Means even though यहाँ पे 16 block का था 3 KB लोड किया फिर भी एक बड़ा block empty रह रहा है. Leftover block is also very big one, that is called as worst fit. And in this block, neither I can load a new process. So that means new process has to wait even though I have the memory space for it. Can you see 10 KB यहाँ पे है, 13 KB यहाँ पे है, 4 KB यहाँ पे है. So that is called as even though my process of 15K, my memory which is available to me is 10 plus 13 is 23 plus 4 is 27. फिर भी मैं उसको load नहीं कर सकती. That is called as worst fit. Have you understood? Everyone. So the solution for worst fit is compaction. What is compaction? Compaction means जितने भी memory blocks available है उनको एक साथ लेके आओ. Let us check. Compaction is a method to overcome fragmentation problem. I will explain what is fragmentation. Let us first observe how compaction takes place. Let us assume this is my memory mapping. Okay. Next, P2 will be swapped out. Next, P2 will be swapped in at this location. एक के बाद एक प्रोसेस को मेमोरी में ऑर्गेनाइज करना इज कॉम्पैक्शन. नेक्स्ट, P4 will be swapped out. P4 will be swapped in. P3 will be swapped out. P3 will be swapped in. And finally, total map जितने भी free blocks थे 27 KB will be kept at the last. Now, can I load P5 into this 15 KB? Yes, that is called as P5 of 15 KB can be loaded and 12 KB is free. This is called as compaction. समझ में आया? Bringing the processes one after the another by maintaining their base and limit register and finally keeping the empty block all together such that more number of processes can be loaded into the main memory. Have you understood what do you mean by allocation techniques, compaction, fixed partition and variable partitioning of memory? Right. Now I will explain the concept of fragmentation. Let us understand with the help of diagram. Suppose, consider this is a memory, right? In this memory block, this is my operating system. This memory block is of, let us say, fixed size. This is my 2K block, this is my 6K block, this is 12K. If the process P1 is requiring 2K, can I load process over here in 2K? Yes, I have loaded. यहाँ तक समझ में आया? Next, suppose I have one more process P2, which takes 9K. क्या मैं 9K process को यहाँ पे load कर सकती हूँ? Answer is no. We cannot load. Rishikesh, I'm muting you. So we cannot load a process P2 of 9K into this empty block. All right. So I will load a process P2 over here in 9K because it is of 12K. All right. So can I say this complete block of 6K is empty now, which is in between empty, which is unused in between? Yes. Can I say out of this 12K, 9K is loaded and 3K is empty for me? मतलब block के अंदर मेरे पास empty space है. There are two scenarios. 6K complete block is empty. 12K में block के अंदर unused space है. All right. Now, अगर मेरे पास next process 5K का आया, will I be able to load into 6K? Yes. Now, if I say I have a block which is coming new to me as the next process, can I load that into this 3K? Maybe of 1K size on? No, I cannot. The reason is यहाँ पे मेरा block 12K का है. 12K का base और limit fix है. Base और limit अगर fix है तो उसके बीच में से कोई process आया तो I cannot insert in between. Are you getting the scenario? Everyone? Means 100% this 3K block will remain unused. Are you getting? So it means that while allocating the processes in the main memory, there are two possible scenarios. One, a complete block remains unused. And second, there can be a small memory amount which remains unused within that block. So the first scenario in which whole partition or whole block which remains unused is called as external fragmentation. And when you say if this partition is being used but smaller amount of memory remains unused, it is called as internal fragmentation. So what is fragmentation? It basically happens when the processes cannot be allocated to the memory blocks even though size is available. Internal means complete block is unused, and internal means inside the block few block of memory is remaining unused. This is fragmentation. So fragmentation avoid करने के लिए हम क्या यूज करते हैं? हम compaction यूज करते हैं. समझ में आया? What do you mean by fragmentation? Everyone, wastage of memory or you can say some unused blocks which are in between the memory blocks. Neither I can allocate new process to it, or nor if they are nor I'm using it. That is called as fragmentation. So this is basically external and internal fragmentation, right? So we have seen something called as in today's class about the memory part, and we completed the process scheduling. In the next class, हम लोग memory को access करने के techniques and we will see the disk